Hello students, I hope you are good, well and fine. Let's begin our discussion on the surface area and volumes, and we will be continuing to discussing about the examples and about the various problems based on the formulas we uh, learned. Okay, so let me first of all recall you the formulas which I already provided you in the previous lectures. So let's start with cuboid. So recall with me. So cuboid total surface area was equals to 2 times the length and the breadth plus the breadth and the height plus the height and the length. Clear? Now the lateral surface area was the area for the 4 walls of a room. So it was 2 times L plus H plus BH, which can be rewritten as 2L plus B times H. Okay. Now the volume for the cuboid was L times B times H. And okay, I hope this all is clear. Whereas the LBH are as follows. So LBH are as follows. The L is my, what is my L? L is my length. So here is my, this is my L, this is my B, and this is my H. Okay, so height, breadth and the length of cuboid. I hope this is clear. Now for cube, just now for cube, it is just nothing but the total surface area is equals to the 6x square, where x is our side of a cube. In cube, all the sides are equal and we are taking our side equal to x. Okay. Now the lateral surface area will be then 4 times x square. Okay. Now the volume will be x cube. I hope this is also clear. Now let's move to the cylinder. Now in cylinder we have the curved surface area. Curved surface area means we have a cylinder like this, and this area marked with red is my curved surface area CSA, which is equals to what? It is just 2 pi r, the circumference of the circle times the height. Okay. Okay. Now now the total surface area, now it includes one thing, which is the the area for these two circles, the at the bottom and at the top. So the area for the circle we know is pi r square, and here is pi r square, and here is also pi r square. In short, we write like 2 pi r h plus r. I hope this is also clear. Now for volume, now for volume, we have pi r square h. Okay, I hope this is also clear. Now let's move to our cone. The cone has also the curved surface area, and the total surface area and the volume. And for the curved surface area, cone is pi rl. Cone is looks like this, where r is my this radius for the bottom circle, radius of the bottom circle, radius. Okay, and h is my this height, this vertex to the point where the radius is, and the length from this is my h or height, and this length I called it as L, which is slant height. Slant height. Okay, so pi r L, and the total surface area is this, the pi r L plus the this area for this circle, which is pi r square, and the volume is pi r square h divided by 3. It is the volume of, if you recall, the volume of a cylinder divided by 3 is the volume for the cone. I hope this is equal. I hope this is understood. Okay, now for the surface, sorry, for the sphere, for sphere we have the total surface area. For surface, for sphere we consider a ball, a solid ball, or sphere. Okay, so the surface area is this part, the whole part. Okay, so it is equals to the 4 pi r square. So the 4 times of the area of the circle. Okay, if you do 4 times of the area of the circle, you will get your total surface area for sphere, where r is the, if this is my center for the sphere, then this is my radius. Okay, so r is the radius of the sphere. I hope this is clear. Now the volume means the how much this sphere can fit in, how much the material, how much the quantity of anything the sphere can fill in itself. So it is the volume, which is 4 pi r cube divided by 3. I hope this is all clear. So now let's move to questions, so where we can apply our formulas and how we are going to apply our formulas. Let's see those approaches also. So let's see what our first question says. So so first question says, if the dimensions of a cinema hall are 100 meter, 50 meter and 18 meter, how many person can sit in the hall? If each person, here we are talking about the person, so if each person requires this much of space or this much of air, we know if a cinema hall is empty, that means it contains a lot of air. So for this we have to find out how much of air it contains. So in order to find out that, we need volume. So volume for the cuboid, as it is a room, or room means cuboid. So we apply volume for cuboid, which is LBH, and we know LBH. So 100 times 50 times 18. Okay, I hope this is clear. So L is my this, BH. Now volume is LBH. Let's moving to the calculations. So this will be my 90,000 meter cube. Always remember, for area the unit was like unit square, and for volume it is unit cube. I hope this is clear. So this much of volume of air is present in the hall right now, and we know a single person, one person uses 150 meter cube of space. So dividing this number by this number, we can get how much of the people can sit in the hall. So we get our answer as 600. Hence 600 persons can sit in the hall. Okay, I hope this is clear. So we used the concept of volume here. Okay. Okay, wherever you are given something like this, you immediately think of volume. Okay, let's move to next. Now the next example shows the outer measurement of a closed wooden box. So we have a closed wooden box. So let me make a wooden box first of all. So here is my wooden box. Okay, so this is my wooden box. I hope it is very clear to you. This is my wooden box. Okay. Now we are given that this whole length is 42. This is my 30 and this is my 27. The length, breadth and the height. Now, if the box is made up of 1 centimeter thick wood. So the material I am using is my box is wooden and this wooden is thickness of 1 centimeter. That means my box from the outer I can it is looking like this, too thick. So let me give the thickness for the box. So this will look like this. I hope you can easily see the thickness of the wooden box. It is thick from the every side. So I am going to do the same for every side. Okay. So that you can easily visualize the box. Okay. So this is the thickness is of 1 centimeters. I hope all is clear to you. The question is very clear and very accurate to what it is asking. Okay, so just now this is my box and here I represented the thickness also. So this thickness, this everywhere it is what? It is of 1 centimeters. So this is 1 centimeters. This is also 1 centimeters. This is also 1 centimeter. So from every side the or the every edge is of 1 centimeter thick. Now we are given the outer dimensions, and if the box is made up of 1 centimeter thick wood, determine the capacity of the box. So now our new box, because the outer dimension are given, so if you are putting anything inside this box, you are using the inner cuboid. Okay, so to find out the how much capacity of the box is, so we have to find out the inner box or inner cuboid dimensions. So this is my 1 centimeter. Yes, this is my 1 centimeter. This is also my 1 centimeter and total is of 42 centimeter. So if I need to find out this length from this to this, I need the 42 minus 1 and minus 1, because one side 1 centimeter from here, 1 centimeter from here, I will get the inner dimension or the inner length is equals to 40. With similar, I can find out here it is 30 minus 2, which is 28, and 27 minus 2, which is equals to 25. I hope the dimension for the new box is very clear to you. Okay, now let's move. Let's see. So 40, so 28 and 25. Now the capacity means for the capacity we need to find the volume. For volume we have a formula LBH. So new L, new B, new H will give me my volume, and this will be cube, centimeter cube. I hope this is clear to you. So 28,000 centimeter cube of capacity it can take. Okay. So I hope this is also clear to you, how we reach to here, why we subtracted 2 from every dimension because of the thickness. Uh, let's move to next. Now this problem says if V is the volume, so if V is the volume of cuboid, we know volume of cuboid is LBH. Okay, with dimension ABC, sorry, not LBH, the dimension are ABC, just replace LBH by ABC. So volume is this, and S is its surface area. If you recall the cuboid surface area, which was equals to the 2 times of length into breadth, which is AB, breadth into height, which is BC, and breadth into the length into height, which is AC. I hope this is clear. Then prove that we have to prove that 1 upon V is equals to 2 by S, 1 by A plus 1 by B plus 1 by C. Let's start with the right hand side. So we are starting with this side. So just plug the value for S and do the LCM for the inner bracket for this. So let's see. So we are starting with this right hand side. By plugging the value for S, we know S is AB plus BC plus CA, 2 times AB plus BC plus CA, and by taking LCM of AB plus BC plus 1 upon A plus 1 upon B plus 1 upon C, which is equals to ABC, which is BC AC plus AB. So it is equals to BC AC AB, and we know both of these quantities are equal, so it get cancelled, and this 2 will also get cancelled. So we are remaining with 1 upon ABC, and we already knew the volume is ABC, so it is equals to 1 upon V. So we proved that the right hand side is equals to 1 upon V, which is our left hand side. I hope this is also clear to you. Now let's move to next. Okay, in this example, the ratio of 2 volumes. So what volumes we are talking about? We are talking about the volume of 2 cones. So let's say we have one cone is like this, another cone. So cone 1, cone 2. Okay, now for volume for this is, we know the volume formula for the cone is equals to the 1 by the volume for the cylinder, which is equals to pi r square h divided by 3. So for this, r is this and h is this. I hope this is clear. Now for here, I am taking r as capital and h is also capital. Okay, now what I have name it V. I am representing V1, the volume for the cone 1 in blue. Okay, so V1 R, and for the cone 2, I am representing volume V2. Okay, so V2 is equal to pi R square H by 3. I hope this is clear. We are given the ratios. That means we are given that V1 by V2 is equals to 4 by 5. I hope this is clear. Okay, and the ratio of the radii of their bases, that means we are also given that the r by r is equal to 2 by 3. Then we have to find out the vertical heights. Okay, so we have to find out the ratio of vertical height. That means we have to find out this. Okay, I hope this is clear to you. So let's see how we are going to approach. Okay, so let's move. So here the terms are different, but the approach is the same. So we are taking the R1, H1, V1, the radius, height, and the volume for the cone 1, and R2, H2, V2, as the radius, height and volume for the cone too. Okay, I hope this is clear. Let me visualize this also. So this is my R1, this is my H1 and the volume is V1, and for this is my R2, this is my H2, and for this is V2, and we know V1 by V2 is 4 upon 5 and R1 by R2 is equals to 2 by 3. I hope this is clear. So by using the formula, so what formula we use? The volume formula for cone. So it is not 1 by 2, it is 1 by 3, because the volume of cone is equals to the area of the cylinder. What is the area of cylinder? It is pi the radius square times the height. Okay, the height divided by 3. Okay, so just I am using this. So by this formula I write like this in the ratio form, and this will get cancelled, pi will also get cancelled, and we are remaining with R1. We are remaining with R1 square H1 divided by R2 square by H2, which is equals to 4 upon 5. I am taking square terms common. So this means that R1 by R2 whole square multiplied with H1 by H2 is equals to 4 upon 5. We know that A upon B whole square is equals to A square by B square. Okay, from this I am writing this. Okay, now we know R1 by R2, it is 2 upon 3. So R1 by R2 is 2 upon 3. I just plugged the value and solved it. So this will be multiply sign. So now I'll get, this will be like this, 2 by 3 whole square times H1 by H2, which is equals to 4 upon 5. Now for solving it, I use first the H1 by H2. Now it is 4 upon 5 times 3 square by 2 square, or just I can also write it like this. Okay, so just whatever is easy, just write like this. I am writing like this because this 2 square is 4 and this 3 square is 9. Due to this, the 4 get cancelled and we are left with only 9 by 5. So 9 by 5 is our ratio. So hence the ratio of their vertical height is 9:5. I hope this is also clear. So we use the concept of, or the formula for the volume of cone. It is quite easy to remember. It is volume of a cylinder divided by 3. Okay, let's move to next. In this problem, it says if H, C and V be the H is my height, C is my curved surface and V is my volume, and these all terms are related to the cone. That means height of the cone, curved surface of the cone, volume of the cone. Let me recall you the formulas for cone. So cone, the curved surface area was pi r L. L means slant height. Okay, so don't confuse with height and the slant height. The height we mean cone is this vertex to the line joining this vertex to the center with the 90°. So this is my H. This length we called L, which is slant height. Okay, slant height, and this is my radius, which is radius or equal to r, say. Okay. Now this is my CSA, or the curved surface area. The total surface area is just the curved surface area plus the area for the circle, which is pi r square, and the volume I just already in the previous slide I gave you the hint for to remember, which is the area for the cylinder, which is pi r square s divided by 3. Okay, so we have all of these things. Okay, so that means CSA is just C, and the H is my H, and the volume is my V. So I am going to use this one and this one. And there's another thing, if you recall, that the relationship, the relation, the relationship between H, the slant height, the height, and the radius is L square is equals to R square plus H square, because if you try to see, this is my 90-degree, and this makes a right angle triangle by Pythagoras. I came to this, so I am using this also in here. So the three things I'm using is, the first one is this, second one is this, and the third one is this. I hope this is all clear to you. So just plug all the values. For V, I am using this pi r square h by 3. For h cube, I am just leaving for it now as h. For c cube, it is just this. And for v square, I am again using the formula for this. And you will get your answer as equal to 0. Okay, so let's see how we are doing that. So the curved surface area is pi rl, and I used the L square is equals to R square plus H square. That means L is equals to root of R square plus H square. Whenever this kind of thing is given, say B here, then if we are removing this 2 from here, then we put root over here. So we did the same thing over here. If a square is equals to b, then a is equals to root b. So applying this, we will get this. And we used pi r l and used the value for L as root R square plus H square. We get this. So my curved surface area is now pi r times root of R square plus H square. Now volume, I already know, the cylinder volume for the cylinder divided by 3. So pi r square h divided by 3. Now just using V here, pi 1 upon 3 pi r square h cube is given. Not sorry, let me see again, see that it is cube or the square in question. Yes, it is cube. Okay, so it is cube. So this will be my cube. Okay, now c square, c, what was my c? It was pi r l. L was a root of r square h square. So c square becomes pi square r square plus h square bracket. Okay, so this is my c square. Okay, h square remains the same. We are not touching the h terms, and v will be my this 1 upon 3 pi r square whole square because of this. Now just solve. So if you see that this 3 will get cancelled, so we are left with, so h will multiply with this term, so the h power 4, r is just there, so r square, and pi is also there, so it will be my pi square, not just equal to square. It is pi square r square h power 4. Now for this, try to see, first we multiply this whole term to the r square. Okay, then we multiply this whole term to this. Okay, so first of all, let's see for the, so minus of pi square r square times r square, it will be minus of pi square r4 h. Okay, I think something has gone missing, or there's little error, so let me clear, so this won't be like this. Okay, I hope this is clear. So now pi square r4 is there. Now what? Just multiply this to this term. Sorry, this is here is also the h square term. All is good. Just there will be r power 4. Okay, I hope this is clear. Let me do it in a clear manner. So I'm writing here r square, pi square r square plus h square. I'm writing this h square to here. Okay, so now just multiply these whole terms for this to this. So it is pi square r4 h square plus pi square r square h4, and the minus sign is here, so I put minus to both sides. So this will be my minus of pi square r4 h square and minus of pi square r square h4. Yes, now it is correct. And for this will become, if you open this bracket, the 1 upon 3 pi r square h whole square, it will give me 1 upon 9 pi square r4 h square. And there is already a 9 here, so we get this 9 get cancelled. So we are left with pi square r square, pi square r4 h square. So pi square r4 h square. I hope all terms are very clear to you. Now try to see that here we have pi square r4 h square, and here we have the same term but the opposite sign. So this will get cancelled, and this term pi square r square h4 is the same as this term but opposite in sign. So this will also get cancelled. So we will left with only 0. So the proof is now done. So hence the proof we did is clear. I hope the proof we did just is clear to you. So just we use the formulas, nothing else. Okay, I hope you had the clear idea how we used all of the formula and what relationship we used when we use volume, when we use curved surface area, etc. And I hope you recall all the formula for cuboid, cylinder, cube, sphere, and etc. So thank you for today. Let's meet again. Thank you.